All right, so, I forgot to write this stuff down. So let me write that. So it's 5-1, new chapter. Now, my honors class did this chapter. They're like halfway through chapter 6 now, I think. But when they did chapter 5, the tests were like crazy good. And it seems like that's the way it is. That's why they're at Circumcenter. Yep. That's kind of the way it is. So really, it shouldn't be that difficult to do. But you do have to know some words, and that's what we're going to do today. There's basically 4 big words that we're going to do, at least for the first 2 sections. Today we're doing Circumcenter and Orthocenter, as you can see. And I'm not going to ask you for the definition for them, but you need to know what's going on here. What am I doing? There we go. Oh, there we go. Oh, that was crazy. I don't know what I just did there. Click something. So you don't really have to write out the definition, but what I'm going to basically do is I'm going to tell you about the Circumcenter, and you need to know what word goes with what, okay? So there's going to be 4 of them. Today we're going to do 2 of them, but on Monday we'll do the other 2. So I'm going to give you a description of the word, and you have to know that Circumcenter goes with that description. Everybody with me on that? So you don't have to memorize the description of it, but you do have to know what the description is and what word goes with that description. Make sense? All right, so it's very important what we're doing, that you know what the Circumcenter is and how we find the Circumcenter. It's important to know what the Orthocenter is and how we find the Orthocenter. All right, that's what's really key about this lesson. Now, before we do Circumcenter, there's 2 things we got to do to prepare us to get to Circumcenter. All right, so I'm not even going to talk about Circumcenter right off the bat. We're going to do some things that kind of prepare you for Circumcenter. So I'm just going to push this up a little bit and going to do this. So I'm drawing a line segment, and on that line segment, see that little blue? Can you see it? It's kind of small. See that little blue dot right there? Okay, that's done by the program. Where do you think that dot is? Well, you could say center. I would understand what you're saying. You could say middle, but what are we going to say? Midpoint. Okay, so this would be at the midpoint of this line segment. All right, this is not a line. It doesn't keep on going forever and ever. It starts and stops right here and right here. And we'll call those endpoints A and B. And this is a midpoint, so we'll use the letter M for midpoint. That makes sense. Everybody with me so far? That's nothing new. You know about midpoint. You know about line segment. But what we're going to do is this. We're going to draw a line that goes through the M. Do you see that? It's going to go through right there. Oops. Don't draw that. Okay, what I'm drawing right now, don't draw. Okay? So, I'm not going to draw it like this. I am not going to draw it like this, even though it goes through the midpoint. I'm going to draw it a specific way. I'm going to draw it straight up and down. Whoops, I missed it, didn't I? Let's push it over. I want to hit that midpoint, and this really, if you wanted to, it could keep going. All right, so this could be a line. But what does it do? It hits that midpoint. Now, how do you think I drew that line? I drew it specifically what? Through the midpoint, and what kind of angle do you think that line makes? A right angle, okay? So I drew that, so it's a right angle. So first of all, it hits it at the midpoint, which means that segment and that segment are equal to each other, all right? Here's a word that we use. We use the word bisect. Have you heard that word before? I think we've done that. I think we've used that word before in here, haven't we? Bisect something? Maybe, maybe not. That's all right. We're going to do it now. Got your phone? All right, so we say that this line right here bisects line segment AB. It bisects it. What does that mean, bisect? Well, the word sect kind of has intersect in it. Intersect means that they just hit each other, right? Okay, what do you think the little prefix bi means? Like bicycle, two, right? So it bisects it, What does it mean that does? If it bisects, it doesn't just hit it anywhere. It doesn't just intersect and touch it anywhere. Where does it touch it? At the midpoint. Exactly. That's what bisect means, okay? So what is this line doing? It's bisecting this line segment. We got that? Why is it bisecting it and not just intersecting it? Because it's hitting it at its midpoint, which means one side is going to equal another side, and it splits it into two equal parts, doesn't it? So that means AM is equal to what? Everybody look up here. AM is equal to just B? MB, right. AM and MB are equal to each other. Why? Because it's being bisected, splitting it into what? Two equal parts. You with me? So that's one word. All right, we're going to learn several words before we actually get up to the one word we're really trying to find, which is circumcenter. Okay? So bisect is very important. Now, it also hits it at a right angle. So it doesn't just hit it at its midpoint. Remember what the thing I did earlier? That hits at the midpoint, doesn't it? Right? This hits at the midpoint, correct? But what does this do that those other two didn't do? It makes it at a right angle. All right? So what's true about those two lines, that line segment and the line? If they hit at a right angle, right? One line's like this, one line's like this. What do we say is true about those two lines? They are, well, the angle is 90 degrees, but the lines, what's true about the lines? It starts with P. Everybody says parallel. In the last class, they said parallel. But is this, look at my arms right here. Is that parallel? No, that would be parallel, correct? What is this? I heard it. Perpendicular. Good. Okay, so what's true about this line and this line segment? They are perpendicular. All right? So there's two things that's true about that line. What does it do? It bisects it, correct? You with me? Why does it bisect it? Because it hits it at the midpoint. What's the second thing that's true about this line? It's perpendicular to this. How do we know it's perpendicular? Because it hits it at a 90-degree angle. Everybody see it? So I give this line right here a special name. I call it a perpendicular bisector. And that's really important because in order to understand circumcenter, you need to know what perpendicular bisector is. All right? It's a really important little phrase. It's a two-word phrase, perpendicular bisector. You need to know that in order to understand what a circumcenter is. And we're still not even ready quite to get to circumcenter, okay? But we're getting close. Everybody good with perpendicular bisector? Again, what's it do? Hits at the midpoint, splits it into two equal parts, and it's also what? It's a right angle, okay? That's the perpendicular part. The bisector is splitting it into two equal parts. All right, enough of that. Let's do a little bit more. I'm going to draw another perpendicular bisector, but I'm going to show you something that's special about it. Whoops. I want to find the midpoint. So the midpoint would be right there. And I'm going to draw a perpendicular line. Actually, I'm going to stop it right at that line segment instead of going all the way through. All right. So if that is equal to that, that makes it a bisector. If this is a right angle, guess what that makes this? Makes this a what? You got it. It's a perpendicular bisector, what we just said. All right? Now, here's what we're going to do a little bit different. So we know what it is now. We know it's a perpendicular bisector. What we are going to do is talk about this next theorem. Here's a theorem that says this. I could take any point on that perpendicular bisector. So let's just draw a point anywhere on this perpendicular bisector. Let's put it right there. Doesn't have to be in the middle, doesn't have to be at the top, doesn't have to be way down the bottom. Just anywhere on here, okay? I just randomly just picked that spot right there. Everybody see that? Now, check this out. What if I went from that point on that perpendicular bisector to the endpoints of my line segment, that original line segment that I drew? If I went from here to there, and then, what am I going to do? Go from that point to where? To the other endpoint, right there. See that? What do you think might be true about those two yellow lines? What does it kind of look like? Well, it looks like a triangle, but compare the two yellow lines. Compare them to each other. Does one look bigger? Does one look twice as big as the other? It looks congruent. Don't they look the same? Like this length right here and this length right here, don't they look the same? Well, they are the same. So we have a theorem that says this. It says that a point on a perpendicular bisector is equidistant. What does that mean? Equidistant. The same distant, right? The same distance from the endpoints of that segment. So here's a perpendicular bisector of this segment. Any point on here is going to be the same distance to the endpoints of that line segment. Okay, any point would be. So let's do another color. What if I did this? What if I picked a point like way up here? Okay, is that on the perpendicular bisector? Yeah. Okay, this up and down one, this vertical one, that's your perpendicular bisector. If I take a point and put it on that perpendicular bisector, what do we say is true? What does this theorem say? It's equidistant from the endpoints of that segment. So if I go from there to there and there to there, what's true about these two green lines then? They got to be equal, right? It's equidistant, right? They got to be the same. Make sense? Does that mean the green ones and the yellow ones are the same length? No. But the two yellow ones are the same length, and the what? The two green ones are the same length. All right, let's do one more. So if you wanted to, you could put a point like way down here on the perpendicular bisector. Doesn't matter where, as long as it's on the perpendicular bisector. And we're getting somewhere with this, okay? I promise. So from there to there is the same, and from there to there is the same. So those two pink ones are also equal to each other. I could go anywhere on this perpendicular bisector, put a point, and if I go from this point to the end point and that same point to this end point, those two lengths are going to be the same. We getting it? Yeah, that's not too hard to understand, is it? All the stuff that we've been talking about for the last, how long we've been talking? Where's my time? 12 minutes. In the other class, I was at 13 minutes, so I'm pretty much the same pace as I was last period. So for the last 12, 13 minutes, we're just leading up to the Circumcenter. So now I think we have enough information to actually be able to talk about the Circumcenter. I'm sure you're so excited, waiting with bated breath, okay, to find out what's true about the Circumcenter. So let's do it. Let's draw a triangle. I'll just draw, kind of looks like a right angle, but it's not supposed to. It's an acute triangle, all right? I got a nice acute triangle. I'll tell you what, let's not make it look so much like a right angle. Let's put it about right there. Because I'm going to do one with a right triangle in a little bit, but right now I don't want this to be a right triangle. So that's acute, that's acute, that's acute. So we got an acute triangle. So what I'm going to do, in order to find the circumcenter, here's what we're going to do. We are going to draw the perpendicular bisectors of all three sides of our triangle. Do you hear what I just said? So I'm going to take all three sides, and I'm going to find the perpendicular bisector of all three sides. So how do I do that? Well, I'm glad you asked, because that's what I'm about to do. So first of all, I need to bisect it, so I got to find the what? What is that point right there? That's a midpoint. That's right. All right, so I'm going to draw a perpendicular line, right, through that midpoint. I'll do that in a second. What I'm going to do now is take the other two sides and find the midpoint. So there's midpoint right there. And here's a midpoint, oops, right there. What did I say we're going to do? Find a perpendicular bisector, correct? So let's do this bottom one right here. So I got to go through this point, and my perpendicular bisector has to make a right angle. So I'm going to start at this midpoint, and then I'm going to make a right angle. You could go all the way through. It doesn't matter that you stop right here. All right? I'm just going to stop right there, though. So what is that red thing that I just made right there? What is that? That is we've said it a bunch of times already today. That's a perpendicular bisector. Why is that a perpendicular bisector? Well, because it makes a right angle, and it hits where? At the midpoint. You with me? Let's do another perpendicular bisector. I'm going to have to eyeball this one a little bit, okay? So that looks right here. See this angle right here? Everybody looking? See that angle right there? I want to make that so it looks like a right angle. Tell me when it looks like a right angle. That kind of looks like a right angle, doesn't it? Again, I'm just eyeballing it. So that looks like a perpendicular bisector. Why is that a perpendicular bisector? Well, hits the midpoint and it makes a right angle. Those two things have to be true. Okay, that's why you got two words, perpendicular and bisector. Bisector means it hits the midpoint. Perpendicular means it makes a right angle. Now, watch this. This is kind of interesting. If I do the perpendicular bisector of the third side, check this out. There's a right angle, okay, hits the midpoint. Look what happens to those 3 points, though. Look what it does. They all hit at the same exact point, which is kind of interesting. For two lines to hit at one point, not that interesting, right? But when all three of them intersect at that point, to me, that's kind of interesting. And there's more that we can know about this. Guess what we found? Guess what that point is called? What have we been trying to lead up to? The circumcenter, exactly right. So that point right there, all right, we'll call it C. All right, that point is called the circumcenter. So let's label some of these other points. This is all we need to label. All right, so C is the circumcenter. So one of the first questions on a quiz and a test, I'm going to say, I forget exactly how I word it, but I'm going to say, what point do you find when you find the perpendicular bisectors of the sides of a triangle? What is that point called when you find the perpendicular bisectors? They all intersect at a point, okay? What is that point called? It's called the what? Talk to me. The circumcenter, that's right. So how did you find the circumcenter? You drew the what? You drew the perpendicular bisector, right? How many times we said that today already? A lot. Perpendicular bisector. So again, like I said, on a quiz and a test, the first 4 problems on your quiz is going to say, how do you find, or what do you find when you find the perpendicular bisectors, or what point? Again, I forget exactly how I word it. I don't have it in front of me. But it's something like, what point are you finding when you find the perpendicular bisectors of the 3 sides of a triangle? Okay, what did you find for the perpendicular bisectors? You found the what? The circumcenter. Okay, that's what you have to write down. You have to write down the word circumcenter. I will tell you perpendicular bisectors, okay? You tell me what? Circumcenter, all right? We got 4 to do. All right, you got to keep all 4 straight. This is the first one. All right, let's put a 1 in front of it. So that's the first one we're going to do. All right. I mean, that's okay. It's kind of interesting, I guess. All right, but it's not the most interesting thing about this. Watch this. What I think is the most interesting thing about this is this. From that circumcenter, that point is pretty special. All right. If I found the distance from that circumcenter to that vertex, you watching what I'm doing? And then the distance from that circumcenter to this vertex, and then, what do you think I'm going to do now? Go to where? Go to Z. If I go to there, what does it look like is possibly true about those 3 yellow lines? They're equal to each other. Exactly right. So that's what's special about the circumcenter. It's one place on that triangle. It's the only place on that triangle that is the same distance from each of the three vertices. Okay? If I would have put a point like right here, is that the same distance from here to, whoops, from there to there to there? No, it's not. All right? How do I find the point that's the same distance to all three vertices? I find the circumcenter. And how do I find the circumcenter? I find the perpendicular bisectors of all three sides. Throwing a lot of geometry vocab at you, aren't I, today? All right? You got to keep all that stuff in mind of what's going on. All right? So that's pretty important. So everybody wants to know, how am I going to use this on a quiz? How am I going to use this on a test? Would you agree? That's what everybody wants to know. So I'll show you. I'll show you the easiest version. They could give you something like this. They could give you a picture, right? They may not even put the yellow ones in there, okay? They'll give you a picture with all the perpendicular bisectors. And they're going to say, if YC is equal to 5, tell me what XC is and tell me what ZC is. It's 5. That's exactly right. Because if this is the circumcenter, if they tell you that point C is the circumcenter, then that means that the distance to all three vertices are the same. So if from YC is 5, then what's XC? That's 5. What is ZC? That's also 5. And that's really what they want you to know. They want you to know that the circumcenter is the same distance to all three vertices. All right? Now, that was pretty easy when they just say it's 5. Do you think they're always going to give it to you that easy? They'll probably put X's in there. Exactly right. Okay? So they may make this like, I don't know, 2x plus 1. And they may make this like 3x minus 2, let's say. All right? I'm just making those up. I don't even know if this comes out nice and even. Yeah, it looks like they probably will. So let's do this. What if they ask you to find XC? What does that mean, XC? When they just put XC, it means the distance, right? Or the measure of line segment XC. So how long is it from X to C? We don't know, but we can figure it out. How would we figure that out? Yep, let's set these equal to each other. Remember, these three yellow lines are equal to each other, correct? Now, on the test, they won't be colored, all right, but you can figure it out. From the circumcenter to the vertex, from here to the vertex, from here to the vertex, they all are the same. So let's set them equal to each other. So let's go 3x minus 2 equals 2x plus 1. Let's do the math on this. It's pretty easy. Subtract 2x from both sides. What would you do next? You know those are going to cancel out. What are you going to do now? I got an x on the left-hand side. How do I get rid of that minus 2? Add a 2. All right, add a 2. All right, that cancels. 3x minus 2x is x equals what? 3. Is that my answer? Does xc equal 3? No. Now, I don't know what xc is. I don't have an x there. Well, I got this x, but I don't have a variable here. So what am I going to do? Just find one of these. Doesn't matter which one you find. Which one you want to find? Let's find yc. It's kind of easy. So what would that be? 2 times what? 3 plus 1. See what I'm doing? Just putting it into that 2x plus 1, right? 2x plus 1. What's this? 2 times 3 is 6 plus 1 is 7. So if this is equal to 7, then what? This is equal to 7. And what else? XC is equal to what? 7. So that's the kind of stuff that they could ask you. All right? It's really the same kind of stuff they've asked you for the whole entire book so far, haven't they? All right? They do that kind of stuff. You learn some geometry. You learn what stuff's equal to each other. Then they throw some x's in there. You do a little bit of algebra. You solve for x. You plug it back in. And then you got your answer. Yes, that's fine. Everybody good with that? All right, so that's the kind of stuff that you're going to do with these things. All right, let's go to the next one. So that's circumcenter. right? Remember that. There's four things you're going to have to remember, and it's hard to keep them straight sometimes. Sometimes it's hard for me to keep them straight. So sometimes I got to go back and look because I forget, all right? So that means that you're going to have to really study, and you're really going to have to remember which one's going to go with what. First one, perpendicular bisector goes with circumcenter. Okay, if you can keep that straight right there, all right, this right here. If you can keep that straight, that's 1/4 of the battle. The next one's actually the easiest one, I think. I'll tell you why in a second. Let's do another word, though, before we do the next one. What's the second big word that we're going to learn today? We did circumcenter. What's the second one? Orthocenter. Okay, we're not going to do orthocenter just yet. I got to learn another word. Just like we learned perpendicular bisector, we're going to learn this word right here, and it's called altitude. I don't know if we've used this word before or not. Has anybody flown in a plane like a Delta flight or American Airlines, big plane like that? Anybody done that? Okay, the pilot a lot of times gets on there and he'll say in his pilot voice, he's got that deep voice, right? Or the woman, I guess. I don't know if I've had a woman pilot. I don't fly that much, but anyway, the pilot gets on there and says, "Oh, welcome to American Airlines. Hope you have a good trip. Oh, we'll be flying at an altitude of 20,000 feet." You ever hear a pilot say that? Okay. Even on movies, TV shows, they'll say that a lot. They say at an altitude of whatever feet. What does that mean? What are they talking about when they're talking about the altitude? So watch. Here's my cool plane. I'm the world's worst artist. Okay. Almost looks like it's dive bombing. All right, but it's going straight. All right. It's going that way. So when the pilot says, "I'm at an altitude of how many feet," what are they telling you? The height. Is it from like there to there? Is it from there to there? What is it? Straight down. Give me a good geometry word, though. Perpendicular. That's right. So when they talk about altitude, they're talking about what? Perpendicular. Now, is this a perpendicular bisector? No. It's just perpendicular. From a point to another point. Okay? And it makes like a lot of people say. Nate, you said straight down. That's fine. Everybody understands what you're talking about. But since we're in geometry, what word are we going to use? We're going to say it's perpendicular. So this is an altitude. The altitude, if I took any point, like if I took a point right there, and I say draw the altitude from this point to this line right here. Okay, the lines are ground. Okay, what would you do? Would you go from there to there? Would you go from there to the end of it? No, you would do what? Make it perpendicular. That would be the altitude. Everybody got that? All right. And if you're flying lower, I don't know why I put it at the same level, what is the altitude from here to the ground? It would be here, not straight down. What do we say? Perpendicular to the ground. Okay. If it's perpendicular, that's the altitude. What's that? Okay. Everybody with me on that? That's what altitude means. So what we're going to do is talk about a triangle. So let's just do some random acute triangle. What if I wanted you to find the altitude? Let's do a different color. Let's say from here. What would the altitude be from this point right here? It'd be from here, where? Would that be the altitude? Would that be the altitude? Where would the altitude be? Give me a word. Perpendicular. Very good. Okay, we use that word a lot today. So this right here, is that necessarily a perpendicular bisector? Is it? No, because it's not hitting the midpoint, okay? This is just perpendicular. So what do we call this right here? We call it a what? An altitude, okay? So that's an altitude. That's an acute triangle. It does make a difference what kind of triangle it is on where the altitude is. So what if I did this? All right. What would be the altitude from this point? You already got it. That's good. I'm glad you saw that. Look, is that the altitude? Is that the altitude? Is this the altitude? Where is it? It's perpendicular. All right. So if the triangle was already a right triangle, then the altitude is just going to be that side of the triangle. Agreed? If it was a right angle? Yeah. So this would be the altitude right there. What if, now this one's a little trickier. So we had an acute triangle, we got a right triangle. What other kind of triangle do you think I'm going to draw? Obtuse triangle, good. So let's draw an obtuse triangle. Again, what if I want to go from the very top of it? You could have started at any of the three vertices, okay? But what if I wanted to start here? What's the altitude to this triangle from that point? Is it from there to there? Is it to there? Is it to there? Where's the altitude? It's got to be what? Like, wait a minute, I can't even make a right angle to that side, can I? But I can do this though, can I? That right there would be the altitude. What would we have to do to that third side though? We have to, extend it. We're going to extend it. All right. See, if I take that third side, well, it's supposed to be a straight across. Wasn't too good. Let's try this again. There we go. That's better. See what I did that third side? I just extended it a little bit. So this right here is our altitude. We good with that? What about from this point? Where would the altitude be on this? Would I go down like that? No, I'd go to the opposite side. Where would I go? To here? To here? No, I'd go about right there. Everybody see that? So that would be an altitude from this point. What if I wanted to do an altitude from this point right here? Where would I draw it? Is that an altitude? Is that an altitude? No. Where would I have to do? I'd have to extend this side, right? I'd have to extend that third side. I'll tell you what, let's extend the third side. So watch, if I extended this side, I'm going to try to make it as straight as I can here. All right. Now, let's see if we can find the altitude. Where would it be? It would be about right there, wouldn't it? See that? So those would be my altitudes to this triangle. All right. So now what I'm going to do is this. What's that second word that we were trying to learn today? We did circumcenter. What's the second one? Orthocenter. So now we are going to find the orthocenter. Let's just use an acute triangle. It's a little easier with acute than it is the others. Now watch what I'm going to do. I'll stay with the red. What I want to do is draw three altitudes. Three altitudes. Where do they start? They always start at the vertex. Okay? So they start from this point, and from this point. But what do I got to do? I got to draw this so that it's perpendicular. Does that look perpendicular? I got to eyeball it. Yep, that looks perpendicular. Okay? Let's draw the altitude from this point up here. So where am I going to draw it? Perpendicular to the opposite side. So that's perpendicular. I got one more to do. I got to go from this one. So check this out. if I draw it perpendicular to the opposite side, guess where it's going to go through? It's going to go through those other two. So again, we have a situation where I got three lines, they all intersect at one point. Do you remember a while back, we actually learned this word. You remember what happens when you get three lines that intersect at one point? We say that those lines starts with a C. No. It's not a circumcenter because this is not perpendicular bisector. They're concurrent. Remember that word? Concurrent. It means the three lines all intersect at what? One point. All right? So we had concurrent, let's see, right? The perpendicular bisectors were concurrent, right? Because they all intersected at one point. And our altitudes are concurrent. Why? Because they all intersect at what? 1 point. Remember how on the circumcenter there was something special about it? Remember I said if you take the length from that circumcenter, it's the same to all three vertices? Well, there's nothing special about the orthocenter, all right? There's nothing special. Like that point right there, yeah, they all intersect at that point, but it's not like it's the same distance to here, to here, to here. There's nothing special about it, about the orthocenter. So really, the only thing that you need to know about the orthocenter is how we got the orthocenter. How did we find that point where they all three intersected? We found the what? Of all three vertices. What did we do? What did we draw? We've been saying that word for the last 10 minutes. Starts with an A. The altitude, right. So how do you find the orthocenter? You draw the what? The altitude. Okay? The altitude from the three vertices, okay? So you start right here, draw an altitude, start here, draw an altitude, and right here, draw an altitude. They all intersect at 1 point. Doesn't matter what kind of triangle you have. They'll all intersect at 1 point, but there's nothing special about that point. With the circumcenter, there was definitely something special about that circumcenter point. What did we say was special about it? It was equidistant, what? To the three vertices, okay? So there was definitely something special about the circumcenter, okay? You found it by the perpendicular bisector, but what was special about it? It was equidistant to the three vertices. How do you find the orthocenter? Find the altitudes of all three vertices. But what's special about the orthocenter? Nothing, all right? Sorry, orthocenter. Maybe they got a bad complex or something, all right, because everybody tells it it's not special, all right? So the orthocenter is just not special. There's nothing really special. The only thing special about it is that all three altitudes intersect at the orthocenter, all right? But there's nothing else. There's nothing special about it. We're going to do two more tomorrow that there is something special about. They're all going to intersect, okay? They're all concurrent. So all four of these, when I draw them, they're all going to intersect at 1 point, okay? So that's what's true about all four of them. Some of them are more special than others. The orthocenter is just not that special. Sorry, orthocenter, all right? But how do you find the orthocenter? You find the altitude. And if you can do that, you should be good. Okay? All right. Here's your homework. So it's section 5.1. It's broken up into two things. I don't know. I should have looked last period. Did I make an A or a B? Shoot. I did. Well, I did tell the other class to watch the end of this video, so maybe they're watching. There might be two of them that are actually watching this. So I'm just going to give you part A, all right? So we'll call this part A. I gave them both parts. I told them to do them both. I'll even put the page numbers on here. So it's pages 209, 210. And you're just doing 1 through 7. I don't know why I only gave you a little bit. That might only be about the circumcenter. I'm not really sure. But anyway, that's what I put on your lesson plans. So we'll stick to it. All right, so 5.1a, 1 through 7. And that's all you have to do. You don't have to do the second part. The second part was 18 to 28. I did tell the other class 18 to 28 as well. So hopefully they are watching this. I told them to watch this. So anyway, there you go. We good? All right, so have that done. No school tomorrow. Well, at least for you guys, I got to come in. But you guys have a long weekend, and so enjoy it. Don't do anything dumb. All right, be good, and come back on Monday.